Lake Mead just rose 1 foot, and the headlines are going absolutely crazy, calling it a miracle comeback. News anchors are smiling, politicians are taking credit, and millions of people across the American Southwest are breathing their first sigh of relief in years. But here is the part they are not telling you. Inside federal water agencies, the scientists who study this reservoir around the clock are not celebrating. They are not popping champagne. They are sitting in front of their screens, quietly running new models. And what those models are spitting out is not a recovery story. It is a warning. Because while every camera in the country is zoomed in on that 1 foot of rising water, something else is happening beneath the surface that almost nobody is talking about. As that water creeps back up the lakebed, it is uncovering things buried for decades. Old toxic mining sites, chemical waste deposits, hazardous materials that looked contained when the lake was dry, but are now being flooded, stirred up, and pushed directly into the water supply that 40 million Americans drink from every single day. The lake is rising, and scientists say it may actually be making things more dangerous, not less. But that is not even the most alarming part of this story. Because buried underneath this so-called recovery is a projection so shocking that some researchers were reluctant to release it publicly at first. A prediction built from years of climate data, federal water records, and hydrological modeling that points to one conclusion: cold, clear, and almost impossible to believe. By 2027, Lake Mead could reach the lowest water level ever recorded in human history. Not the lowest in a decade, not the lowest since the Hoover Dam was constructed, the lowest, ever, in all of recorded human history. And the reason is something that one miraculous snow season and 1 foot of rising water cannot fix, because the Colorado River Basin has been running a water deficit for over 20 years. States have been withdrawing more water than the river can replace. The legal agreements governing who gets what were written during one of the wettest periods in the last 1,000 years, and scientists now know those numbers were never realistic to begin with. So ask yourself the question that nobody in Washington seems willing to answer out loud. Is this 1 foot rise proof that Lake Mead is finally healing? Or is it the last deceptive calm before the most catastrophic water collapse in American history? Lake Mead just rose 1 foot, and on the surface, that sounds like good news. After years of devastating decline, after record lows that left boat ramps stranded in the desert and bathtub rings of white mineral deposits climbing hundreds of feet up canyon walls, the water is moving in the right direction. Headlines celebrated it. Local news ran the story with optimism. And for a region that has spent the better part of a decade bracing for a water catastrophe, even 1 foot feels like something worth holding on to. But 1 foot is also about the height of this screen you are watching right now. And when you are talking about a reservoir still sitting approximately 160 feet below full capacity, one that serves drinking water to 40 million people across 7 states, 1 foot is not a comeback. It is barely a rounding error. Here is what the celebration is missing. In 2023, Lake Mead rose by over 20 feet. That was a genuine surge, driven by a once-in-a-generation snowpack in the Rocky Mountains that sent meltwater pouring into the Colorado River at volumes that shattered every forecast. The Bureau of Reclamation had projected the lake would drop by 20 feet that year. Instead, it rose by 20. A swing of 40 feet in the wrong direction from what the best models in the country predicted. That is not a forecast error. That is a fundamental breakdown in the science of predicting water in the American West. Lake Powell, the reservoir sitting upstream that feeds directly into Lake Mead, surged by more than 50 feet in that same period. Together, the two reservoirs looked like they were staging a dramatic recovery. And yet, even after all of that, after the record snowpack, after the historic meltwater surge, Lake Mead was still 160 feet from full. Still critically, dangerously short. And now, 1 year later, the gain being reported is 1 foot. Not 20, not 10, 1. That single foot represents a system that burned through its snowpack windfall almost as fast as nature could deliver it. The cities are still growing. The farms are still irrigating. The evaporation accelerated by rising temperatures is still pulling water from the lake's surface every single hour of every single day. Nature delivered a miracle in 2023. The Colorado River Basin consumed it in roughly 12 months. The 1-foot rise is not the number keeping federal scientists awake at night. The number keeping them up is 2027, and what their models are projecting for that year is something the Southwest has never faced before in recorded history, not even close. To understand why the 2027 projection is so alarming, you have to understand how bad things already got. Most people who saw the headlines about Lake Mead's rise do not fully grasp what came before it. Without that context, 1 foot of rising water sounds like progress. With it, 1 foot sounds like standing at the edge of a cliff and taking one small step backward. From 2016 to 2022, Lake Mead did not just decline, it collapsed. Year after year, water levels dropped further than the year before. By mid-2022, the reservoir had fallen to just over 26% of total capacity. More than 3/4 of Lake Mead was simply gone. The bathtub ring, that pale white band of mineral deposits left behind as the water retreated, climbed nearly 180 feet up the canyon walls, a visible scar marking exactly how much had been lost. Ghost structures emerged from the lakebed, sunken boats, old docks, and in one deeply unsettling discovery, human remains, multiple sets, surfaced from sediment that had not seen daylight in decades. July 2016 was the moment warning lights started flashing at the federal level. Lake Mead hit what was then its lowest recorded water volume in history, and government officials began running calculations nobody wanted to see. If the trajectory continued, downstream users would face mandatory cuts, not voluntary reductions, mandatory ones. The cities, the farms, the ecosystems that depend on Colorado River water were all looking at a forced reckoning with the reality that there simply was not enough water to go around. The cause was not one bad drought year. It was 20 years of accumulated deficit. The Colorado River Basin endured one of the driest 2-decade stretches in the entire historical record, compounded by a booming regional population consuming water at a rate the system was never designed to sustain. Nevada's population had grown explosively. Arizona's cities were expanding into desert land that required massive water infrastructure. California's agricultural demands remained enormous. And through all of it, the river kept being asked to give more than it had. Emergency measures began rolling out. In 2020, engineers installed low-level intake pumps specifically designed to pull water from depths previously unreachable, a technical admission that the reservoir might keep dropping past points any planner had seriously prepared for. Political battles erupted across the basin. Tucson, Arizona made the extraordinary decision to voluntarily forfeit portions of its Lake Mead allotment. Nevada began drafting legislation to cap residential consumption in ways never attempted anywhere in the United States. This was Lake Mead before the snowpack surge of 2023 arrived. Not struggling, not under pressure, failing. And the 1-foot rise being celebrated today is happening in a system that never fully recovered from what those 6 years did to it. So where did the water actually come from? The answer is not a policy breakthrough. It is not a technological miracle. It is snow. Specifically, an extraordinary, record-shattering snowpack in the Rocky Mountains during the winter of 2022 to 2023 that produced meltwater volumes the Colorado River system had not seen in a generation. Snowpack is essentially a natural reservoir suspended in the mountains. Through winter months, snow accumulates across the Rockies, building up a frozen reserve that slowly releases as temperatures climb in spring and early summer. That meltwater feeds the streams and tributaries flowing into the Colorado River, which eventually reaches Lake Powell and then Lake Mead. In an average year, this process is steady and predictable. In 2023, it was neither. It was extraordinary. The winter snowpack exceeded typical seasonal levels by enormous margins across critical areas of the upper Colorado Basin. As spring arrived, the melt came in waves that overwhelmed streamflow forecasts. Measurements that had been running grimly below average for years reversed sharply upward. The Bureau of Reclamation was forced to publicly revise its 24-month outlook in a way that essentially admitted its models had completely failed to anticipate what was happening. Expected declines became sharp gains almost overnight. Cooler than average spring temperatures amplified the effect. When spring warmth arrives gradually, snowmelt releases over a longer window, reducing the volume lost to rapid evaporation. In 2023, That extended melt window meant more water reached the reservoir than would have under a faster, hotter spring. Every variable broke in Lake Mead's favor simultaneously. The result was that 20-foot rise that stunned the water management community. But here is what those headlines left out. Climate scientists framed what happened not as a recovery signal, but as a statistical outlier in a system trending sharply in the wrong direction. One exceptional snow year cannot reverse decades of structural overdraft. The Southwest is getting hotter. Evaporation rates are increasing. The long-range precipitation outlook remains drier. And the Rocky Mountain snowpack, over the arc of decades, is projected to shrink as rising temperatures turn more winter precipitation into rain. Rain that runs off quickly instead of storing itself in frozen reserves for a slow spring release. What 2023 delivered was a gift. A genuine, remarkable, one-season gift that the models did not predict and may not repeat for years. The Bureau of Reclamation celebrated the gains while simultaneously warning that the underlying vulnerability had not changed. The water came, the water is being used, and the models looking toward 2027 are no longer counting on another gift arriving in time. Here is the part of this story that almost nobody is covering, and it is arguably more alarming than the 2027 projection itself. While water managers are focused on quantity, a completely separate crisis is quietly unfolding along the newly flooded shoreline, one that has environmental scientists working around the clock and asking questions that do not have easy answers yet. When Lake Mead dropped to its historic lows, the retreating waterline pulled back like a curtain, revealing decades of lakebed that had not seen open air since the reservoir was first filled in the 1930s. What was sitting on that lakebed was not just sediment and rock. It was history, human history, the kind that accumulates over a century of industrial activity, mining operations, and land use along the Colorado River corridor, and the kind that was never meant to see daylight again. As the water rises and floods back across that exposed lakebed, those sites are not being cleaned up, they are being submerged. Old mining operations that left behind chemical residues and heavy metal deposits are now being inundated. Toxic materials that appeared contained when dry are in direct contact with rising water. Environmental agencies are racing to assess how much contamination is leaching into a reservoir that supplies drinking water to 40 million people. The monitoring is urgent. The answers are not yet fully in. The sediment problem is equally serious. Decades of pollutants settled into the lakebed over the reservoir's long history. Heavy metals, industrial residues, and chemical compounds that stayed undisturbed while the water was stable are now being remobilized. As new currents form with the rising water level, those sediments are being stirred. The contaminants locked inside them are moving. Aquatic ecosystems that depend on stable lakebed conditions are already showing signs of stress. Fish populations face disruption from contamination spreading through water they cannot escape. Then there is the debris. As the water climbs back up the canyon walls, it covers old foundations, submerged equipment, and abandoned structures that accumulated over a century of human activity. Just below the surface, this debris creates invisible hazards for boats, swimmers, and wildlife. Navigation charts that managers relied on for years are suddenly unreliable. Safety teams are scrambling to map what is now lurking beneath a lake that millions of recreational visitors use every year. Invasive species are taking advantage of the disruption, exploiting altered ecosystems to spread into areas they could not previously reach. Once they gain a foothold in a system as interconnected as Lake Mead, removing them becomes extraordinarily difficult. The rising water was supposed to signal a return to normalcy. Instead, it has opened an entirely new set of problems. The lake is coming back, but what is coming back with it was never supposed to resurface at all. Now comes the number that federal water scientists do not say out loud in press conferences. The number discussed in technical briefings and internal modeling sessions, but rarely included in the public statements water agencies use to reassure a nervous region. The number that explains why, even as 1 foot of rising water generates celebratory headlines, the mood inside the agencies managing Lake Mead is something closer to dread. By 2027, according to projections built from years of climate data, federal water records, and hydrological modeling, Lake Mead could reach the lowest water level ever recorded in human history. Not the lowest in recent memory. Not the lowest since the Hoover Dam was completed in 1936. The lowest level this reservoir has ever held in its entire existence. A level so far below anything previously recorded that it would represent a complete failure of the water system. The American Southwest has depended on for nearly a century. The math behind that projection is not complicated, which is part of what makes it so hard to argue against. The Colorado River Basin has been running a structural water deficit for over 2 decades. The states and users drawing from this system collectively withdraw more water each year than the river generates in an average year. That gap has been masked at various points by wet seasons, conservation measures, and the 2023 snowpack windfall, but it has never been closed. The debt keeps accumulating. Lake Mead is where that debt ultimately shows up. The legal framework made things worse before anyone realized it. The Colorado River Compact, signed in 1922 and dividing the river among 7 states, was negotiated during one of the wettest periods in the last 1,000 years. The flow estimates used to write that agreement were optimistic even at the time. Modern science has confirmed they were significantly overestimated. A legal system built on numbers that were never accurate is now being asked to manage a crisis those numbers helped create. Climate projections for the Southwest through the late 2020s offer no relief. Rising temperatures mean higher evaporation from the reservoir surface. Reduced snowpack means less reliable meltwater. And the feedback loop tightens with every degree of warming. More heat means more evaporation, lower lake levels, harder choices for every user in the basin. Scientific debate exists around the 2027 scenario's precise timing. Some researchers argue the projection reflects worst-case modeling assumptions. Others contend those assumptions are not worst-case at all, that the conservative models may actually be underestimating the decline given the pace of warming already recorded. That disagreement among experts is itself alarming. When scientists are debating whether the situation is as bad as the worst-case model or worse, the answer for 40 million people depending on this water is the same either way. 40 million people. That is not an abstract statistic. It is the actual number of human beings in cities, farming communities, tribal lands, and suburban neighborhoods across 7 states, whose access to water is directly tied to what happens inside that reservoir. As the 2027 projection circulates through water agencies and policy circles, the question of who bears the cost is no longer theoretical. It is the most urgent political argument in the American West. Start with Las Vegas. The city draws approximately 90% of its water directly from Lake Mead, not partially, as its primary lifeline. Every hotel fountain on the Strip, every residential tap in Henderson and Summerlin, every cooling system keeping hospitals running in one of the hottest cities in North America, all of it flows from the same reservoir that federal models say could hit historic lows within 3 years. Las Vegas has invested genuinely in conservation and water recycling. But 90% dependence on a single failing source is a vulnerability that no amount of efficient showerheads can fully offset. Arizona sits at the center of the political firestorm. The state is simultaneously one of the fastest growing in the country and one of the most exposed to mandatory water cuts. Its agricultural sector, historically among the largest consumers of Colorado River water, is being asked to absorb reductions it has resisted for decades. Meanwhile, cities like Phoenix and Tucson are expanding into desert landscapes that require enormous water infrastructure. The competing demands within Arizona alone, urban growth versus agricultural survival, represent a conflict that state officials have not come close to resolving. California's position adds another layer of tension. Agricultural communities in the state's Colorado River corridor hold some of the oldest and most legally protected water rights in the basin. Senior water rights get served before junior ones during shortage conditions. California farmers have watched other states absorb cuts while their senior rights protected them. That arrangement is increasingly unsustainable, and the resentment it generates among other basin states is poisoning negotiations that need to succeed before 2026. Tribal nations represent perhaps the most complicated dimension of this reckoning. Indigenous communities across the basin hold federally recognized water rights that were systematically ignored for most of the 20th century. As the compact approaches its 2026 expiration, tribal water claims can no longer be sidelined without legal and moral consequences that basin states are not prepared to face. The Glen Canyon Dam bypass proposal crystallizes the impossible choices at the heart of this crisis. The plan would fundamentally alter how water and power are managed across the basin. Proponents argue it is necessary. Critics warn of economic devastation to communities dependent on hydroelectric output. Nobody disagrees that the status quo is failing. What is being negotiated right now, across boardrooms, federal offices, and tribal councils, is who absorbs the pain of a system that has been overpromised for a century. And the 2027 clock is not waiting for anyone to reach a comfortable answer. The solutions exist. That is the part of this story that deserves to be said clearly, without false comfort, but also without despair. The tools, technologies, and policy frameworks capable of extending Lake Mead's viability are real. They are being deployed, and in several cases, they are already producing measurable results. The problem is not a lack of ideas. The problem is whether the scale and speed of implementation can outrun a 2027 deadline, now less than 3 years away. Start with agriculture, because that is where the math is most unforgiving. Farming consumes the overwhelming majority of Colorado River water. Estimates consistently place agricultural use above 70% of total basin withdrawals. Conservation progress in cities, however sincere, cannot move the needle fast enough on its own. Efficiency gains in irrigation technology, crop switching, and voluntary fallowing programs, where farmers are compensated for not planting, represent the highest leverage interventions available. Some are already operating. None are operating at the scale the 2027 projection demands. Nevada's proposed residential water legislation would be the first of its kind in the United States, capping household water use in ways no American state has previously attempted. The fact that such a proposal is even being seriously considered reflects how completely the political calculus around conservation has shifted. Voluntary measures had their moment. What is replacing them is the uncomfortable recognition that mandatory limits with real enforcement may be the only path forward for urban water users in a basin running out of options. The 2026 expiration of the Colorado River Compact is the single most consequential legal deadline in American water history right now. The agreement has governed this river for over a century, built on flow estimates wrong from the beginning, strained beyond design limits for decades. Renegotiating it requires 7 states, federal agencies, tribal nations, agricultural interests, and environmental groups to reach consensus on a new framework that distributes real scarcity fairly. Negotiators describe the process as extraordinarily difficult. The 2027 projection adds urgency that the negotiating table has not yet fully absorbed. Renewable energy integration offers one underappreciated avenue of relief. Lake Mead's hydroelectric output through the Hoover Dam depends on water levels. As the reservoir drops, power generation drops with it. Accelerating solar and wind build-out across the Southwest reduces the pressure to draw down water levels just to keep the lights on. Real-time monitoring technology, satellite data, and AI-assisted hydrological modeling have given water managers situational awareness impossible a decade ago. The information infrastructure to manage this crisis intelligently exists and is improving. What lags behind the data is the political will to act on what that data is clearly showing. Every expert who studies this system agrees on one thing: the tools to avoid the worst outcomes are available. The window to deploy them at the necessary scale is narrowing faster than the public conversation around Lake Mead currently reflects. 1 foot. That is where this story began. 1 foot of rising water in a reservoir already 160 feet below full capacity, celebrated as a comeback by headlines that did not stay with the story long enough to see what was underneath it. 1 foot that masked toxic sites flooding back into a drinking water supply serving 40 million people. 1 foot that obscured projections pointing toward the lowest water level in recorded human history within 3 years. 1 foot that bought time in a system so structurally compromised that time alone cannot fix it. The Colorado River has sustained human civilization in the American Southwest for centuries. long before the Hoover Dam was built, long before the 1922 Compact divided the river into legal allocations. Indigenous communities understood this waterway as something to be respected, carefully used, and never taken for granted. That understanding eroded steadily through the 20th century as cities expanded, agricultural operations scaled up, and legal agreements written during anomalously wet decades created the illusion that the river had more to give than it actually did. The debt that accumulated through that illusion is now coming due, and Lake Mead is the ledger where that accounting happens in real time. The scientists who study this system are not alarmists. They are doing what scientists do, following the data where it leads, and reporting what their models show, even when what they show is deeply uncomfortable. What they are showing right now, for 2027, should be commanding the full attention of every elected official, every water manager, and every resident in the 7 states that draw from this river. It is not commanding that attention. Not yet. Not at the scale the situation demands. That gap between what the data shows and how urgently the public and political system is responding is perhaps the most alarming part of this entire story. The tools to address this crisis exist. The legal frameworks to renegotiate water sharing are being assembled, however slowly. The technology to conserve more efficiently and model more accurately is better than it has ever been. What is missing is the shared acknowledgement that the moment for gradual, comfortable, politically convenient action has already passed. Lake Mead does not care about election cycles. It responds to physics, to evaporation rates and inflow volumes and temperatures, climbing whether or not the policy conversations are keeping up with them. And right now, the physics are not pointing toward recovery. They are pointing toward 2027. The water level rose 1 foot. The headlines moved on. The scientists kept running their models. And somewhere beneath the surface of that reservoir, beneath the newly flooded shorelines, beneath the disturbed sediments, beneath the rising waterline the cameras celebrated, the clock those models are tracking keeps moving forward toward a deadline that 40 million people are not yet fully prepared to face. The question is no longer whether Lake Mead is in crisis. The question is whether enough people are paying attention before the water tells them itself.